The hydrocarbon used in the production of styrene is A. Ethyne, B. Propyne, C. Ethane, and D. Ethane. So obviously the keyword here is production of styrene and also hydrocarbon. Well, for one, all our options are actually hydrocarbon. So let's see if we can further eliminate our choices. So production of styrene. How exactly is styrene being produced? Styrene is obtained from a reaction. Okay, let's just keep it simple. We have benzene. Basically, benzene undergoes a reaction with ethylene to form ethyl benzene, and this compound is then dehydrogenated to form styrene. So we have dehydrogenated here, and the name of this reaction is alkylation, but we don't really have a business with that. So the starting elements are benzene and ethylene. Obviously benzene is not here, so our next focus is on ethylene. Definitely not ethyne, not propyne, not ethane. The other name for ethane is actually ethylene. So that makes option D our answer. Moving on, we move on to question 12. Question 12 says, which of the following contains two amphoteric oxides? A. Sodium oxide, zinc oxide, magnesium oxide. B. Aluminium oxide, calcium oxide, zinc oxide. C. Potassium oxide, lithium oxide, carbon dioxide. And finally, option D. Silver oxide, lead oxide, and sodium oxide. So first and foremost, what exactly is amphoteric oxide? So amphoteric oxides actually refers to oxides that can serve as both what? Acids and bases. So it means whenever they react, whenever amphoteric oxides react with acids, they form salt and water that's undergoing the normal neutralization reaction. And also whenever they react with bases, they form salt and water also undergoing the same neutralization process. So we have metal. They are all metal oxides. However, we can spot that some are different. So generally, group 1 and 2 metal oxides are basic. So it means that they cannot act as both acids and bases, rather they can only act as what? Bases. So first things first, we have to eliminate the group 1 and 2 metal oxides. So we can see sodium, which is a group 1 element, so out, magnesium out. And since the question requires us to identify the option that contains 2 is already out here, so it can't be option A. Aluminium, calcium is out. Aluminium is group 3, zinc is actually a transition metal. Potassium is group 1, so out. Lithium is group 1, so out. So this automatically is out. So we have silver, lead, sodium. So the only options are option B and D. Interestingly enough, both are actually correct because aluminium oxide, zinc oxide, silver oxide, and lead oxide are all amphoteric oxides. However, for your level now, the moment you hear amphoteric oxide, what should come to mind should be aluminium and zinc oxide. So with that option B, we take option B as our answer. Remember, it can also be option D, but because of your level and all, are expected to have been exposed to only aluminium oxide and zinc oxide. So moving on to question 13, sorry. Question 13 says, local black soap is made by boiling palm oil with liquid extract of ash. The function of the ash is to provide the A, acid, B, ester of alkanoic acid, C, alkali, and finally D, alkanol. So first things first, we have to look at how exactly is soap being made. So in organic chemistry, you'll find this in your part 2 of your new school chemistry textbook. So generally, soap production is called saponification in organic chemistry, and the process pretty much involves your fat and oil reacting with an aqueous alkali in the presence of heat to form alcohol, let's make that alkanol and soap. So in this question now, the local black soap, obviously that's our product, is made by boiling palm oil. So palm oil will replace fat and oil. Boiling, obviously, we said in presence of what? Heat. With liquid extract of ash. So we are more or less saying palm oil plus ash equals soap. So ash is equivalent to what? Alkali. So that means when they say the function of the ash is to provide it won't be acid or ester of alkanoic acid or alkanol, rather it's going to be what? Alkali. So that makes option C our answer. Moving on, question 14. Oh, an easy one. So ideally there's some questions that you don't have to spend more than 10 seconds on. And this is a typical example. So which of the following substance is not a homogeneous mixture? So what exactly is an homogeneous mixture? An homogeneous mixture, now think of tea. We know tea is made up of sugar, we have water, we have milk. Let's just stick with these three. When looking at the tea, you can't really separate it into just sugar, water, and milk. You can't say, okay, this is the sugar portion or the water portion or the milk portion. Everything seems so uniform. So that's the key word in homogeneous mixture. So now we just have to look at these options. Which of them does not look uniform? So filtered seawater. So filtered seawater, the word filtered means all debris have been removed and we're just left with water. Can you really say, okay, we know water is H2O. Can you really say this is the hydrogen part, this is the oxygen part? No, so that means option A is not our answer. Soft drink. Same analogy with our tea. We can't really separate it into the flavor and the sugar and the water, so it means that it's also what? Uniform. So it means it can be soft drink. Writing ink is also uniform. Our only option left is option C, and that's the correct answer. Our further explanation on this, we have flawed water. Due to the mention of the word flawed, we can expect that it's going to contain debris, stones, sand particles, even wood, or perhaps refuse itself. So it means that you can separate it and it's no longer uniform. And because it's no longer uniform, it's not an homogeneous mixture. So again, flawed water is the correct option. Moving on, move on to question 15. A pretty interesting question. So in the diagram above, Y is a mixture of A, calcium hydroxide and ammonium chloride, B, calcium hydroxide and sodium chloride, C, sodium chloride and ammonium trioxonitrate 5, and D, sodium dioxonitrate 3 and ammonium chloride. So to explain this, although I actually have an issue with this question, you would see what I'm talking about in a couple of minutes. So let's try to go over it. So pretty much Y was heated and you got products ammonia and calcium oxide. So we have something like this: Y, ammonia and CaOH. But ammonia is a mixture, so it contains two compounds. So it means two compounds would react to give us ammonia and calcium oxide, ammonia and calcium oxide. So now let's look at the reaction of each and every one of these mixtures. So let's do that here. A, we have calcium hydroxide as CaOH2 plus ammonium chloride, so that's NH4Cl. That would pretty much give us calcium chloride plus ammonia and water. Option B, that's calcium hydroxide. Now we are not really bothered with balancing the equation since our focus is just in the products and reactants. So calcium hydroxide and sodium chloride, this is pretty much a displacement reaction, so there is a swapping out. So what we eventually have is sodium hydroxide plus calcium chloride. Option C, sodium chloride, that's NaCl plus N-ammonium thiazonitrate 5 gives us NH4Cl plus sodium thiazonitrate. So option D, we have sodium thiazonitrate, so that's sodium thiazonitrate 3 plus ammonium chloride NH4Cl, and that gives us sodium chloride plus NH4NO3. Now let's compare it with what we have here. So obviously it can't be this, so option D is out. It can't be this, option D is out. It also can't be this, option D is out. Personally, I think this was a mistake. Rather than oxide, it would have made more sense to be what? Calcium chloride. So due to by method of elimination, it can't be any of these three. So I would go with what? Option A. So assuming there's an issue with the question, option A would have been the what? Correct answer.